Hey guys, this is Jim WT1W and you're watching FEP Labs Radio. Thanks for stopping by. Appreciate it. Today I want to talk about the Tiny Spectrum Analyzer, or TSA you'll hear it called. No, not that TSA, the Tiny Spectrum Analyzer TSA. And this is a pretty cool little device. It runs around $150 or $160, and I will put a link below in the description for where you can get this from. First things first, this is a sponsored video. This was sent to me by the good people at rsync, and I'm going to do a video review and we're going to talk about it, but they don't get to see the video before I publish it, and they have no input into the contents of the video. All right. Also, any links I post for this, specifically Amazon, will be an affiliate link. It doesn't cost you any extra money, but I do get a little share of that and it helps out the channel. So I appreciate it. So this is the Tiny Spectrum Analyzer Ultra, and the biggest difference between this and some of the older models is the frequency range that this thing can handle. And this particular one goes up to around 7 gigahertz, which is way more than most of us are ever going to use as hams. What is a spectrum analyzer? Well, first let's take a look at this. That does not come with it. That was mine. I've had this open already. When you get the TSA and you open it up, this is what you get right here. This comes with an input and calibration ports and output ports. It also comes with a screen protector. So we get that in the kit, and then the rest of the goods, including the manual, can be found right there at that QR code. And that is tinysa.org. And that's where the user manual is and how we actually unlock ultra mode on this guy. Now, we're not going to be using ultra mode today because there's nothing I have that requires that high of a frequency range. So this is a USB-C chargeable device down there. It will also take an SD card so we can save measurements and readings with it. It comes with a stylus. I like to call this a guitar pick for touching things on the screen. It is a touch screen. It's a resistive touch screen. It comes with an external antenna that we can use to test for noise in the environment, for example, RF signals floating around us. And I've done a previous video with a Tiny SA on how to search for noise with something like a Tiny SA. This also comes with a female-to-female adapter, so we can plug any cables we need to into this. It also comes with a stylus as opposed to the guitar pick stylus, and this is the kind I generally prefer to use with these things. And it comes with 2 cables. These would be male SMA on both ends for connecting to the Tiny SA. Now, one of the biggest things people ask, is this good? Does this work? Yeah, they work. They work fine. The difference between this and a real spectrum analyzer is a low-end real spectrum analyzer. Real spectrum analyzer, first of all, is not portable. This is very portable. You can absolutely take this out in the field, outside, and do what you need to with it pretty much wherever you are. It has a built-in battery. It's chargeable, like I said, via USB. And it does not say what the battery size here is, but it is 1.3 max amps input at 5 volts USB, or draw to charge the battery. This particular one, because this is an ultra, covers from 100 kilohertz to 900 megahertz, and then from 900 to 7.3 gigahertz in ultra mode. Now, a low-end real spectrum analyzer starts around $1,000 and they go up from there. A true lab-grade spectrum analyzer is in the 5 figures. I mean, it's more than $10,000. I have a Siglent SVA 1015X, which is a spectrum analyzer / VNA. It's not super high-end, and it was about $1,700. So 10 times the cost of this. It is also not portable. It is about 1 foot long and 8 inches deep and about 6 inches high, and is made for benchtop use. It runs off 120 volts. So it is not really designed to be used in the field. Now, before we go too much further and look at this, let's talk about what is a spectrum analyzer and what are some differences between potentially this and a real spectrum analyzer. So a spectrum analyzer displays and measures signal amplitude, which is the signal strength versus the frequency. So here is the strength on this piece of the graph on the y-axis, and on the x-axis we have the frequency. So the difference between this, for example, and an oscilloscope is an oscilloscope measures amplitude versus voltage, or versus time, rather. So on an oscilloscope, this is amplitude, which is the same. This is also amplitude, but the oscilloscope is over time, and this is over frequency instead. So that is the main difference between a spectrum analyzer and an oscilloscope. Frequently, you'll hear people refer to them as scopes in general. It's not exactly a scope, but it has a scope, face. So, you do you, boo-boo. The one caveat, if you get nothing else out of this video, is that you must understand that you need to put an attenuator on this before you start keying up a radio. If you're only going to ever use HTs, a 40 dBm attenuator, 40 dB attenuator is perfectly fine. If you think you're going to plug your 100-watt Kenwood into this, or ICOM or Yaesu or whoever, you need at least a 50 dBm attenuator, and I'd probably go for 60, because the front end of this will not take that much power. You will let the magic smoke out, the light will escape, so you must have an attenuator. I will put a link to some attenuators in the description below, also Amazon affiliate links. Do not run your radio into this without an attenuator in line, at least 30 dB, at least 30 dB. Very important safety tip on this. What do you use a spectrum analyzer for? These are used to find interference, which is the previous video I've done. These are we use these to look at radios, and I've done a number of videos on these, as have other ham YouTubers, where we'll plug in an HT radio and key it up, and we can see our primary signal and any harmonics that come out of that radio. All right, I've got our setup here, and I'm going to run through what we're doing, and then I'm going to zoom in so we can see the tiny SA much better than now. So this is a 40 dB attenuator. This is the cell wave attenuator. This is rated for like 200 watts. I've done multiple videos with this guy, so that's the one we're using. You can also find much smaller attenuators on Amazon and multiple places. This guy is made for high power. 40 dB covers about anything I'm going to do with it, so that's what I'm using. Now, 40 dB would not be enough to filter out an HF radio at 100 watts going into this thing, but turn down the juice on your HF and you still be fine. Okay, so what I did is I went to the measure, and then I said harmonic, and it asked me what frequency, and I told it 146.52. And so that's where we are. Now we're picking up some noise here, but this is at minus 70 dB. So I am on 146.52, and we're running into the dummy load / attenuator, so nobody's going to hear anything. And it will take it a second, and it's sweeping a range right now up to about 600 megahertz. And you can see our primary is about minus 10 dB, and there are no appreciable harmonics coming out of the radio. So that is a quick test of how you would measure harmonics. There's some other tweaks you can do, and we could set those up. But again, all the instructions are on tinysa.org. I just wanted to demo this one function real quick. Now, the next thing we're going to do is we're going to set this up, turn that off, and we're going to set this up to be a signal generator, mode, signal generator, low output on, frequency 146.52 megahertz. Modulation, we're going to go with FM. And as you can hear and see, we are receiving. So that's pretty sweet. And if I turn it off, no modulation. We have a carrier, but we've got no modulation on top of that FM signal. So we'll go back, we'll turn that off, and that closed out our transmission. Those are some of the things that you can use it for. And you can verify that a device complies with wireless standards. A large difference between something like this and something like a full-size bench spectrum analyzer is the dynamic range. What is dynamic range? That's the ability to measure very large and very small signals at the same time. So the dynamic range is to be able to discern weak signals in the presence of a strong fundamental or primary main signal. That's the biggest thing with dynamic range. The limits are the boundaries of the spectrum analyzer. So this is the maximum power this is the limitations that sets that dynamic range, is how much power can this handle before the signal gets distorted and or compressed. The lower limit on a spectrum analyzer is going to be its own internal noise, known as the noise floor, or the official term, and you should write this down, there will be a test later, is the displayed average noise level, or DANL. Okay? Those are a couple terms, and those are some differentiators between a bench size spectrum analyzer and something like a tiny SA. That doesn't make this bad. It's a smaller tool. It is much less expensive than a mainline spectrum analyzer. And for almost everything you do as an everyday amateur radio operator, this thing works great. The other thing that you look at is spurious free dynamic range, SFDR. And that's the cleanest measurement window. It's the range you can measure before the analyzer starts making noise to muck up your readings, okay? False signals, spurs, or distortion. And those can be mistaken for your real signal. The spurs come from electronic components. Nothing is perfectly linear, no electronic is. So that non-linearity can create intermodulation distortion. And in looking at RF signals, that's typically third order intermod distortion, which creates the ghost signals near your real signals. Okay? Way more background than I really wanted to get into on this. So the big trade-off with something like this obviously is size. This thing literally will fit in a cargo pants pocket. And I know all hams love cargo pants. You can't put a benchtop spectrum analyzer in a cargo pocket. It won't fit. That's the big difference. Something like my big SA, my Siglant, is it's more of a prosumer, or I hesitate to say lab grade because it's not really lab grade, but it is a higher quality instrument than something like this. Again, at 10 times the price with no portability. If you're interested in getting something like this, again, this does pretty much everything the average ham would ever need to do. The functionality on this versus a full size is exactly the same. I can plug a radio into this, and I can look for harmonics when I key up the radio. So for example, if I key up on 146.52, I can look at the second, third, fourth order harmonics to see if they meet the FCC specifications for handheld radios, for 2 meter and 70 centimeter style radios. So that's something everybody can do, everybody. The other thing is looking for interference, which again was a previous video I did. I can put the antenna on this and walk around and look and see what might be causing interference in my shack. Why am I hearing that ungodly hum on 40 meters, for example? We can also use this to characterize filters. This will generate its own signal. It's called a tracking generator function. We can generate a signal and run it through a filter, for example, a bandpass filter or a low pass or high pass filter, and see what the filter's cutoffs are, the upper, lower, etc. filters. So again, can do the exact same thing with this that I can do with the very expensive benchtop SA. So it does a lot of the same things. This generates signals. That's called the tracking generator function. The frequency range, we've already talked about this. A physical difference is obviously this screen is much smaller. You can't really see the beautiful screen because of the reflection. This screen is much smaller than a benchtop. This is like a 4-inch TFT LCD screen, 480 by 320. The benchtop spectrum analyzer is going to be an 8 or 10-inch screen, twice or 2.5 times the size of this screen. But they're not portable. This runs on a 3000, I found that information. This runs on a 3000 milliamp hour rechargeable battery. And you can also connect this to a PC and using some software, drive this with software on your PC as well. So this is a great tool to have in your toolkit, especially for something where you're operating portable, either POTA or field day or SOTA. If you're really hardcore and want to carry this to a mountain, again, you do you. Okay, I wanted to show you what the screen looks like outside. So I'm kind of in shade right now. I can see this very well. I don't know how well the camera will pick this up. I've got an HT that I'm holding here, and we're going to key up on 5.2. And you can see that very well. It's a lot easier to read in person than it is on the camera because you're getting a bit of my big head reflecting. Let's move out into the sunlight. So I am standing in direct sunlight. The sun is behind us at this point. And the screen is still pretty easy to read. Obviously we've got some reflections. So let's try this again. And there we go, I'm keyed up. So, you know, the reflection makes this harder to see, especially for the camera. But I'm having no problem seeing this outside. So this is a very nice screen on this. I really like this, and it's clear enough to read outside, certainly in direct sunlight. And this is kind of a worst case situation because the sun is behind us. The signal generator performance, and this is a very key point with this guy, and I want to mention this specifically. This has a built-in signal generator. This will generate a sine wave up to 800 megahertz. I have a signal generator that only goes to 60 megahertz, and this little thing will generate a signal up to 800 megahertz, a sine wave. A square wave up to 4.4 gigahertz and up to 5.4 gigahertz in ultra mode. The output power on that signal generator is adjustable, and we can change the modulation on it and do amplitude, AM modulation, or FM modulation. Again, to characterize filters and see what the output of a radio looks like. So those are some pretty cool things. The firmware is actively updated. I will find a link for that and put that in the description as well. And the interface is pretty decent. I have no complaints about it. And if you've ever watched any of my videos or my live streams, you know me and Temporarily Offline will vetch about an interface all day. So we can pause our reading. We have preset menus we can go into that we can load at startup. So if we have a particular set of settings we want to use for something like measuring harmonics on a HT, we can set this up and then save that into an empty slot and have it load that as a default. We also can save these settings to and from an SD card, which is very useful. Of course, go back, takes us back. Frequency here we can set and these settings are identical. These settings are identical to most spectrum analyzers. Our start frequency. So if we want to test, let's say we want to test an HT on 2 meters. I want to start at 140 megahertz. And then I'm going to hit my menu again, and I want to set my stop frequency to 500 megahertz. And then that is my 2 meter HT test. I can save that as a preset and go right back to it anytime I want. We can also tell it how much attenuation we have. So if I'm testing something that has a higher output than this can take on the input, I'm going to run it through an attenuator, something like a 30 or a 40 dB attenuator. And I can tell the TinySA I'm using a 40 dB attenuator, so it will take that into account for any measurements. So while I'm attenuating the input signal, what I'm seeing is actually what the radio's putting out in spite of it running through a 40 dB attenuator. We can turn on different traces. We can also do calculations. If we're going to test a filter, we want to hook the filter in line. Before we hook it in line, we're going to run a cable between these two. We're going to hit normalize, and that's our 0 line, for example. And then we can put our filter in, and we'll see the difference that the filter has done from the 0 line. And we can also save these traces again to SD card. On our measurement, we can also look at other things besides harmonics. Of course, here's presets for harmonics. So the other thing I mentioned is that we can put on our external antenna. This is exactly what I did in a video with an older Tiny SA several months ago. And I can extend this whip antenna, and you can see now we're picking up some RF signals here from putting on the antenna. So I have a overhead fluorescent light running. That may be what some of that is. Let's turn that off. Nope, still doing it. Actually, I'll just leave that light off. You can see the screen a little better. But as I move around and as I touch this, of course, things change. We have one signal over here on the left side that's fairly strong. So this is RF that's floating around here. If I turn on different lights, maybe we'll get some more noise. I'm right by an LED light there. Moving it around the antenna. There's a large spike, so that's, I think, from my light. Yep, that was from the light. And as I turned off the light, of course, that interference went away. And that is, honestly, more so than testing HTs, that is a very good use case for a device like this, because as I mentioned, and as my previous video talked about, stick the antenna on this, charge up your battery, and go walkabout and find out what is generating RF noise. So, and you see we're picking up something here. Now this is a signal at about minus 35 dBm right now. And the frequency is at 581.2 megahertz that we're picking that up. And because of the settings, it put a marker on it automatically for us. So that's pretty swank. So this is the Tiny SA Ultra. And again, this device runs around $160, and there will be a link below as well as a link to the documentation. I'll put all that in the description. I think the value on this is outstanding, and if you're interested in exploring RF, this is a great way to get started with exploring. Guys, that is all I've got for this video. I hope you enjoyed it. If you would give me a thumbs up, make sure you share this with your friends. Subscribe to the channel. If you're not subscribed, it will make you happy. And ring the bell so you get notified whenever I post any new content. Thanks, y'all. 73. Have a great day.